So the previous questions that we had on our reflection, it was we were describing. Yes, we had to describe what is happening between the object and the image, and we saw that it was just a consideration where the mirror line, it is vertical or it is horizontal. Those were the typical questions that we had. And it was just something that is direct, because if the line is vertical or horizontal, let us consider to say the mirror line is drawn through this line, which passes through the point 2. We know that the equation of this line is just direct. X is equal to the X value that you're given there, which is X is equal to 2. The same way, if you're given a line passing through 1, which is a horizontal line passing through -1, that is the equation of the line y is equal to -1. So these lines, they are direct, as we can see from our normal algebraic functions. We had that. So this is what we had before. Now it's a continuation. We want to see other typical questions that you might have on the reflection. Given triangle ABC, which is the same triangle that we had before with vertices at A, B, and C. So we are going to mark our points. The point A, which is 1, 1. So that's the point A, 1, 1. So you've got the point A. The point B, 2, 1. Going to mark the point B. And also the point C, which is 1, 3. So you're going to mark the 3 points, then join as previously. So this is what you are going to have. All right, so let's just change. Yes, must be straight here. All right, so I think gonna have something of this nature. So you just have to join properly, guys, with your ruler. We have got a triangle ABC. And also the image, we have got the image A1, which is -1, 1B, 1C1 that we are given. So we are going to mark our points, which is the points on the image. So A1 is -1, -1. That is -1, -1. When X is -1, Y is -1. So this is our A1. B1 is given as -1, -2. So let's just write this A1 aside like this. So B1 is -1, -2. So this is our B1. Then C1 is -3, -1. -3, -1. This is our C1 like this. So this is what we are having on the image. These are the coordinates that we are having on the image. Okay, so we are going to join just like previously. A1 to B1 the same way, this side and also this side like this. Okay, so this is what we have as our image. The image, because we are given to describe the transformation which maps triangle ABC onto this. So that is our image. ABC being our object. We were going to join the corresponding points because we can see the object and the image at the same. I think now, guys, we are used to this. I talked about this, the translation, rotation concept. So you join A to A1. Let's just have this. A to A1. You also join B to B1. You also join C to C1 using the broken lines. So by joining, we can see that these lines, they are not going to meet at any point. They will never meet. They are truly parallel. But if we are to consider now the issue of the length by just looking at C, A to A1, look at this distance, compare it with the C to C1. Look how big C to C, compare with B to B1. These parallel lines that we have produced, they are not equal. They are not equal. So if they are not equal, it means that is a reflection. Remember, a translation is the one when the parallel lines are of equal length, but for a reflection, it is the one that are when we have these parallel lines of unequal length. So we can now describe to say it is a reflection. Remember, the question was to describe. So it is a reflection. I also said you are going to also need the equation of the mirror line, the equation of the mirror line. So that is my major part now of this question, because if we were to consider these typical lines that we have, remember, to determine or to have this equation of mirror line at the end, you must have the equation, you must have the mirror line first. By bisecting any of these combinations, is it A to A1? Is it B to B1? It's a choice. So in this case, I'm going to take A to A1. Okay, let's bisect. You bisect any combination of your choice. That line is going to pass through the same line. So in this case, I'm going to bisect A to A1. That part is for any. You can choose whatever that you want. B to B1, you can choose C to C1. That's a choice. That's your choice. As long you bisect properly. Remember, to bisect a line, I'm going to need this point A. All right, at point A here, the needle point at point A. Then you just open more than half of the line. It's already more than half of the line. So I'm going to have an arc this side and the other side. All right. So I'm going to have my arc here and also do the other arc on this side. I do not know where this line is going to pass. So I'm just going to try to extend this arc. Okay. Then I do the same thing at point C. So, at point A1, remember we are working with A and A1. Do not change this length, the distance that you opened, do not change it. All right. So whilst the needle point is at A1, whilst you are having your needle point at A1, you can draw an arc this side. Okay. Just the same way your construction in your normal construction. So that is, as we can see, these two, they do meet at a certain point. Where these two meet, we can join. So this line was going to pass like this. If we were to join properly, it was going to pass like this. It was going to pass like this. All right. So this is the type of the line that we're going to have. This line, it's only that you see these graphs, they when you use them, they'll be a little bit shrinked, but it is supposed to be dividing these lines into equal parts, into two equal parts. This line is supposed to divide your graph into two equal parts like this. That is how your line is supposed to look like. This is the line bisector of A to A1. If you were to bisect B and B1, your line bisector, it was going to pass through the same points, 1 minus 1, 2 minus 2, 3 minus 3. If you were to bisect C and C1, it was going to pass through. Try that. Just try to bisect C and C1. B and it is going to pass through the same. That is why I'm saying you choose any combination. That part is not going to affect. What is important is that you bisect the line, and from that line bisector, the line bisector is your mirror line. That is your mirror line. So you need its equation now, the equation of the mirror line. You need the equation of the mirror line. So look at the line that you're working with. It's no longer a vertical line, the one that you're used to. It's no longer a horizontal line, the one that you're used to. Look, it's a slanted line, slanted. So we need the equation of this line. How do you determine the equation of a line given just a line like this? How do you determine the equation? Remember, to determine the equation, you are going to need the points. You're now back to your algebraic graphs, your straight line. So you can just take any 2 points which lie on the line. Just use any 2 points. You are going to need any 2 points on the line. Now we have to determine the equation. So any 2 points, let's say I'm going to use this one 0, 0 on the origin. As you can see, our line passes through the origin 0, 0. So I'm going to take the point 0 versus 0, and I'm going to take this one 1 versus -1. This one at the point which lies on the what? On the graph. X is -1, x is 1, y is -1. So the point is 1 minus 1. Remember, you take the x value followed by the y value. So how do you determine the equation when given 2 points? Remember, you're going to need the gradient first, which is your m, the gradient, which is the change in y over the change in x. That means we're going to have x1, y1, x2, y2. All right, y2, that is -1 minus y1, that's a 0 there, over x2, which is 1, minus x1, which is a 0. So if you were to divide -1 over 1, that was going to give us -1. So this is our gradient m. So remember I said to determine the equation of a straight line, the equation of a line given 2 points, the equation of a straight line can be written in the form y is equal to mx plus c, where m is the gradient. M is the gradient, this one, that's your m. So meaning to say y is equal to, in place of m, you substitute your gradient -1x. So -1x simply means minus x plus c. So you need to determine the value of c, where c is the y-intercept. So you can even take it from the graph to say, according to our graph, the y-intercept, that's a 0 there. Or you can just substitute any point that you're given. X1, that's 0, 0. You can use point x2. It's up to you, x2, y2. So using the point x1 with a 0, 0, what does it mean? It means I'm going to substitute the y value. Y is equal to 0. If x is equal to what? If x is equal to 0, like that. So as we can see, we can't say -0. 0 is equal to 0. So it means c is equal to what? It means c is equal to 0. So if c, which is the y-intercept, is a 0, therefore our equation y is equal to what? Y is equal to -x plus a c, which is a 0, of which -x plus 0 is what? It's -x. So that's the equation of the mirror line. So if you understand these lines, guys, from your algebraic graphs, we must know, even by just looking this type of a line, we must know this line. This is the line of y is equal to -x. We also have this line of y is equal to x, which divides our graph also into 2 equal parts, but it is having a positive gradient like this. This is the one of y is equal to positive x, y is equal to x. But this one that we are having with a negative gradient, that is the line of y is equal to -x. So this is our mirror line. That's your mirror line. Y is equal to what? Y is equal to -x. So you are going now to write that equation you are describing here. It is a reflection. Then the equation of the mirror line, what is our equation? Y is equal to -x. That is to describe fully. That's to describe fully. So as you can see, it needs you to revise back your algebraic graphs, how to determine the equation of a straight line, this and that. But this is how your questions might be. So let us conclude with this one. Let us conclude with this one. Also with the same triangle ABC with those vertices that we were given before, we're just gonna have a repetition of the same triangle A. It was 1, 1. So this is our A. B, it was 2, 1. And C was given as 1, 3. So this is our C. Then we have to join our triangle. So this is our triangle ABC. Okay, so that is going to be our triangle ABC. Then also we are given the image of the triangle ABC, A1, B1, and this. So you're supposed to describe the single transformation which maps ABC onto A1, B1, C1 with 0, 2, 0, 3, and 2, 2. All right, so let's mark our points. That's 0 versus 2. 0 versus 2, this point here. All right, that's our A1. So A1 is 0 versus 2. B1, that's 0, 3. B1, that's 0, 3. So that's our point B1. Then C1 is 2, 2, 2, 2. It's here. Okay, that's our C1 here. Okay, so this is what we are having. Let us join our triangle and see what we are going to have at the end. What are we going to have at the end if we are to join? This is it. All right. So we want to know the single transformation which maps this ABC onto the triangle A1, B1, C1. As we can see, the triangle A1, B1, C1 and ABC are the same. They are congruent to each other, very, very congruent. They are congruent to each other, congruent. So meaning to say, in order for us to conclude the transformation, we need to join, just like the previous case, A to A1, B to B1. So let's join and see what is going to happen. A to A1, you join with the broken lines. B to B1, you join again with the broken lines. C to C1, you join with the broken lines like this. So if you had to consider properly, I joined A to A1, B to B1, C to C1. What am I producing here? These two lines, they will never meet. These two lines, they will never meet. So it means these lines are parallel. But are they of equal length? No. Let's measure A to A1, B to just look, B to B1, how big it is. These two are not of equal length. It's true they are parallel lines, but they are not of equal length. They are unequal. They are of unequal length. So which transformation is that? That's a reflection, where the two triangles or the object and the image are congruent figures. They are congruent. But as they are congruent, if you join the object to the image, you form parallel lines of unequal length. So you now describe it is a reflection. This is to describe. It is a reflection. Then what are you going to need? You are going to need the equation of the mirror line. Equation of the mirror line. The mirror line. So the equation of the mirror line is the one that I said you must bisect now first, the corresponding combination in order for you to have the mirror line first. So we are going to bisect any corresponding. Is it C to C1? Is it B to B1? Is it A to A1? That one is a choice. Okay, so I'm going to take A to A1 and bisect this line. The combination that you choose, it is going to pass through the same with the one that with someone who chose a different combination. The bisectors will pass through the same point. So let's say we choose to bisect A to A1. Let's say we choose to bisect A to A1. So I'm just going to open more than half this side of A. That is more than half. So with the more than half, we can locate a position where this can be. All right, sorry for that. So this is more than half, so I can just somewhere there draw an arc. Okay. Let me just change this one. So I'm just gonna draw an arc this side. That's an arc. Then on this other side, I'm also gonna have an arc. This side, we're gonna have an arc this side. That's A2 to its point, an arc there, an arc there. Then you do the same thing to A1. So you move on to where A1 is. This is where our A1 is. So you're gonna have an arc also without changing. Do not change this length as you construct. Okay, remember your construction. Do the same. On this other hand, you do the same. So we are going to notice that these bisectors, they do meet. at this point, and at this point. So where the bisectors meet, you are going to join now where these two bisectors meet. So it was going to be, okay, let's just use a continuous line. So it was going to be like this, passing through these bisectors like that. Okay. So your line was going to be a little bit like this. Okay. Something like this. So this is your line passing through the bisectors, passing through this bisector, passing through this bisector. So you bisected this line A to A1. It is the same bisector for B and B. It is the same bisector for C, and you just bisect one. So that is our mirror line, this one. This is our mirror line. So this line, it is passing through -1, 0. It passes through 0, 1. It passes through 1, 2. It passes through 2, 3. It passes through 3, 4. These are the points that we are going to have along the line. So we need the equation of this line. So that's why I'm saying now, to determine the equation, that's where we need to go back to our lines. We consider that part, taking of 2 points. You can even consider the gradient by movement. Gradient is the change in y over the change in x. So you can even see that to change in y 2 units over 2 units, that the gradient is 1. The y, you can even take this one direct. Remember, the equation is y is equal to mx plus c. And the gradient is the change in y over the change in x. So y, that's 2. I mean, that's 1 unit in y, 1 unit in x. So it means 1 over 1. Y is equal to 1, which is the gradient. So it's going to be 1x, which is just x, plus c is the y-intercept. The line passes through the y-intercept at what? At 1. If you know this, do it. Just write your answer direct. There's no need for you to to determine the gradient. Write your answer direct. But now, if you do not understand this, that's where you have to consider your points. In order for you to have the equation, you need the gradient. So you're going to take any 2 points along the line. So I can even take this point, -1, 0 there. So the points along the line, there is a -1 and a 0. The -1, 0, and you take another, as long as you've got 2 points. So we're going to also take this one, 0 versus 1. That's 0 versus 1. So these are the 2 points that we have on the line. So we can determine m, which is our gradient. Remember, I said gradient, which is m, is the change in y over the change in x, y2 minus y1 over x2 minus x1. So that's our x1, y1 here, x2, y2. So that's y2, which is 1 minus y1, that's a 0 there, over x2, that's a 0 minus our x1, which is -1, like this. So this is what you're going to have. So at the end, that will be 1 minus 0, which is 1 over 0 minus -1, which is 1, and 1 over 1 is 1. So as you can see, it's the same answer that we obtained by movement. Increase in y over increase in x, 2 over 2, that's a 1. Increase in y over increase in x, 1 over 1, which is a 1. You can determine your gradient from what? From the graph, straight. You can determine that. That's your gradient. So having the gradient, now we determine our equation, remembering that the equation is given of the format y is equal to mx plus c. Y is equal to mx plus c, where m is the gradient and the gradient is 1. So that's 1x, which is just x, plus c. So c is the y-intercept. If you can see that the c is the y-intercept, which is 1, you can just write your 1. But if you can't realize that, therefore, you go back to the points that you indicated before. You have to substitute any of these points, -1 versus 1. So there is a point. You just take 1 point. You can even use this one. It's up to you. So that there you have got x and y. Y, that's a 0 there. So in place of y, we're going to have a 0 is equal to x. So x is what? X is -1. So it's going to be -1 plus c. So now we can determine the value of c, transposing -1 to the other side of the equation. That will be a +1. So 1 is equal to c. So if c is equal to 1, therefore our equation is going to be y is equal to what? Y is equal to x plus c, but our c is 1. So therefore, y is equal to x plus a 1. So as you can see, it is exactly the same equation that we had before, exactly the same equation that we had when I was demonstrating by the movement, to say we can even calculate this, determine this equation by movement. So that is how you can determine your equation. You are back now to the determination of the equation. So we having the equation, therefore we can conclude that the equation of the mirror line is of y is equal to x plus 1. So when you are to describe and you've got this type of a line, these typical lines, you have to consider how to determine the equation of a line, how to find the equation of a line given 2 points. Make sure I revise that. So we shall have the last part of our reflection, where you are given now to draw the image given the object. So make sure that you tune in for that.